Hey grade 11s and welcome to this video. In this video, we will be working on the grade 11 mathematics paper 2 and this is for June 2025. This paper is specifically from the Limpopo province and the marks allocated is 100 marks and we have 2 hours to finish this paper. Okay, so the instructions, just remember to round off to 2 decimal places unless stated otherwise as usual, and the diagrams are not necessarily drawn to scale. Okay, so with that being said, let's get into this paper. Question 1 says, in triangle ABC below, we have point A, which is -3 and -1, point B, which is 4 and 6, and point C, 6 and -2. We need to calculate the length of AB. Okay, so to find the length of a line, we simply need the distance formula, which is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so with A and B, you can use any one as point 1 and point 2. So if we take this as point 1, we're going to just say x2 point 2 minus point 1's x. Okay, so this is AB is equal to, and we find the square root of x2 minus x1, so that's going to be 4 minus -3. So if you say 4 minus -3, you see how this will become a plus 3 because of that negative times negative, all squared. And then we have y2 minus y1, and that is 6 minus -1. So 6 minus -1, which just becomes a plus 1, all squared. And then go ahead and enter this into your calculator and let's get our answer. And our answer is 7 square root 2 units. And moving on to the next question. Question 1.2 says, find the coordinates of the midpoint D of AB. Okay, so the midpoint of AB. So we're still using these points again. But now we just need the midpoint formula. So the midpoint formula is x1 plus x2 all over 2, and then y1 plus y2 divided by 2. Okay, so let's go ahead and see this. So we'll say x1 plus x2. So that is -3 plus 4 over 2. So -3 plus 4 over 2. And this will be the coordinates of D. And then -1 plus 6 over 2. So that's -1 plus 6 divided by 2. And finally, D is, if we say -3 plus 4, that is 1. Divided by 2 is just 1 over 2. And then 6 minus 1 is 5. So this is just 5 over 2. And that is the midpoint of AB. Moving on to the next question. Question 1.3 says we need to calculate the angle of inclination, alpha, of the line AB. Okay, so to find the angle of inclination of a line, remember that is that angle that the line creates with the x-axis. To find that, we need the gradient of this line. So the line AB, as you can see, is an increasing function, so it has a positive gradient, and we already have 2 points on the line, so we can actually find the gradient. I'm just going to go ahead and take the points down. So to find the gradient of a line, we say change in y, okay, y2 minus y1 over the change in x, so x2 minus x1, and this is equal to, so the gradient of AB is, and we're just going to follow one order. I think it's best to just take these ones as 0.2. So that is 6 minus -1, which becomes a plus 1, all over 4 minus -3, which becomes a plus 3. So we have 7 over 7, which is equal to 1. So the gradient of AB is 1, meaning the angle of inclination will be found by saying tan theta equals our gradient, which is 1. Then if we transpose tan, then we're going to get the second function of tan. So if you say shift tan of 1, you see that you will get 45 degrees. Okay, and they actually call this alpha, not theta, so I'll just go ahead and call it alpha. So the value of alpha is 45 degrees. Moving on to the next question. Question 1.4 says, calculate the angle of inclination, beta, of the line BC. Okay, so this time is of line BC. We already know how to find the angle of inclination. I'm just going to fill this in. We know that this is 45 degrees. And so to find this, you can already see it's an obtuse angle. Okay, so definitely the gradient of this line is going to be negative. So let's just go ahead and take B and C down. So the gradient of this line would be found by saying the y2 minus y1. So let's just go ahead and this time we can take top minus bottom, it's fine. So this is 6 minus negative 2, which becomes a plus 2, all over 4 minus 6. So this is going to be 8 in the numerator. In the denominator, we're going to get a negative 2. So 8 divided by negative 2 is negative 4. Okay, so this is the gradient of BC. And now we can say tan theta equals our gradient. This one is called, okay, beta. So let's say tan beta equals our gradient, which is negative 4. And then we can go ahead and transpose tan. So beta equals, but here's the thing about this. In the minute you say shift tan and then you say of negative 4, you're going to get a negative angle. So shift tan and you say negative 4, you get a negative angle. And here's the thing. You see, with this line BC, what it is measuring is the size of this angle. Okay, we don't want it to measure this. So that's why it's negative 75.96 degrees. We want it to measure this angle. And so to get to that angle, you see that we've measured this way, really clockwise. Okay, angles are supposed to be measured anti-clockwise. That's why our angle is negative. So what we can do is just add 180 degrees to this. Okay, because see, if you are here and you add 180 degrees, you get to this point of 0 degrees, and then you get to this point. So that is a full 180 degrees that has been added, and that will give you the size of this obtuse angle. Okay, so just say plus 180 degrees, and there we can see the size of that angle. So plus 180 degrees, and so this means that beta is finally just 104.0, and that's going to be 4, okay? 0.4 degrees. It rounds up to a 4. And that is our answer. Moving on to the next question. Question 1.5 says, calculate the size of angle ABC. Okay, I'm just going to go ahead and get this diagram down. We can use it down there now. Okay, so you see how this angle ABC is this angle over here they're referring to. So this is ABC. How do we find the size of this angle? Well, we can actually find the size of this angle because it is created by these two lines, AB and BC. Now, we know the angle of inclination of line AB, okay, and then BC. Okay, if you had to extend these lines, do you see how they intersect and then they create this angle, which is vertically opposite this angle, ABC, which we're looking for? So all we have to do is find this angle over here. Now, here's how we can find it. We are going to draw an imaginary x-axis. So it's a line that is parallel to the x-axis. Okay, and if we move this up to this point where that angle is created, we can actually see how to find this angle. So do you see how if this is the x-axis, then the angle of inclination of the line BC, okay, will go from this imaginary x-axis all the way to that line BC. And then we could also find the angle of inclination of the line AB. Okay, now that looks like that. So if you took this entire angle and you said all of that minus all of this, do you see how you'll be left with that part in the middle? Okay, and then that is angle ABC because it's vertically opposite it. So that's how we can find it. We already have the angle of inclination of line BC and the angle of inclination of line AB, and so we can find that. So that angle, angle ABC, call it angle ABC, it is found by taking beta minus alpha, and then we'll find it like that. Okay, so 104.04, 104.04 minus, and we have alpha, which is 45 degrees. And this is all we need to find. Let's go ahead and find that. And our answer is 59.04 degrees. And that is it for this question. Moving on to the next question. Question 1.6 says, determine the equation of the line passing through A and B. Okay, so it's the equation of a line. So it is in the form of y equals mx plus c, meaning we first need to find the gradient and then find c, or at least one point on the graph that can help us find c. So they've given us 2 points A and B, and so we can just use them to first find the gradient, which we already have. We have the gradient of AB. The gradient of AB from the first question was 1. Okay, so just go ahead and find C. So you can use this equation, or you could use this one. So I'll just go ahead and use this. Y minus y1 equals m times x minus x1. Okay, and so in place of m, we fill in the gradient. Now in x1 and x2, you're just going to substitute 1 point on AB since this line passes through A and B. So I'll take B because it's easier, 4 and 6. So B is simply 4 and 6, and this is x1, this is y1. And so we say y minus 6 is equal to 1 times x minus 4. And so this is equal to, they multiply and they just stay x minus 4. And we have y equals x minus 4. And this comes over to become a plus 6. So 6 minus 4 is positive 2, meaning finally y is equal to x plus 2. And that is our answer. And that is it for question 1. Question 2 says, ABCD is a parallelogram with vertices A, and we have 4 and 6. So let's just fill that in. That is 4 and 6, negative 4 and 6. And then B, which is 3 and 5. C, which is 0 and negative 2. And D is X and Y. Determine the length of AC, okay, in simplest third form. So just find the length. We already know the distance formula from question 1, so you can just go ahead and start substituting. That is fine. So we have A and C. So x2 minus x1, we can just go ahead and start with top minus bottom. So that is negative 4 minus 0, all squared, plus 6 minus negative 2, which will just become a plus 2, all squared, and then sub into your calculator, and let's get our answer. Okay, and that is 4 root 5 units. Okay, 4 square root 5 units. And that is our answer. Moving on to the next question. Question 2.2 says, determine E, the midpoint of AC. Seems to be following a similar flow to question 1. But okay, so we need to find E, the midpoint of AC. Okay, so to find E, just use those points A and C. The midpoint of AC would be found by taking x1 plus x2, so I'll just say negative 4 plus 0 over 2, and then y1 plus y2 over 2. 6 plus negative 2. So if you say 6 plus negative 2, you see how positive times negative will just give you a negative. Okay, so it's just 6 minus 2 over 2. And so finally, this point E they're referring to is negative 4 divided by 2, which is negative 2. And then 6 minus 2 is 4 divided by 2, which is positive 2. Okay, so negative 2 and 2. Moving on to the next question. Question 2.3 says, determine the coordinates of D. Okay, so D was that missing one, but we just previously found E, which is negative 2 and 2. So this all depends on what this shape is. They call this shape initially a parallelogram. So here's something we know about parallelograms. You see, in a parallelogram, the diagonals of a parallelogram, they bisect each other. Okay, so I'm just going to put E here instead. So what it means for the diagonals to bisect each other, all that means is, you see, this diagonal is bisecting this diagonal, meaning it's cutting it into 2 equal parts, making this equal to this. And then this diagonal DB is also bisecting AC, meaning this is equal to this. And all that means is that E is the midpoint of AC, but E is also the midpoint of DB. So we can actually use this to find D, because in this line DB, we have its midpoint, we have one of the endpoints, we can find this endpoint using the midpoint formula. Okay, so let's go ahead and find that. So using the midpoint formula, we're just saying we are trying to find the midpoint of line BD or DB. And we'll find that by saying x1 plus x2. Okay, so I'll take this as x1. Okay, just because I want to keep the x first. So that is x plus 3 over 2. So x plus 3 over 2. And then y1 plus y2. So that is y plus 5 over 2. Okay, y plus 5 over 2. But here's the thing. We already know what this midpoint is. The midpoint of DB is this E. Okay, so something we can tell them is we know that the midpoint of BD is exactly the same thing as the midpoint of AC. So because of that, we're just going to go ahead and put that midpoint over there. That is that negative 2 and 2 that we had. We know that this is exactly the same as that midpoint of BD, but this is just the calculation for the midpoint. So on one hand side, we have the actual midpoint. On the other hand side, we have the calculation, but they stand for the same thing because they're both the midpoint of BD and AC. So that means that their x values are exactly the same. So we're going to equate their x values, meaning negative 2 is actually equal to x plus 3 over 2, and 2 is equal to y plus 5 over 2. And now we can go ahead and solve for x. Okay, so here we solve for x by getting rid of this 2. So you can just multiply both hand sides of the equation by 2. So times 2 times 2, that gives us over here, the 2's cancel and we have x plus 3 equals, and this gives us negative 4. Transpose the 3, so x is equal to negative 4 minus 3, which is negative 7. Okay, so we have x there. And then find y. So to find y, you can multiply both hand sides of this equation by 2 to get rid of the 2 in the denominator. And so y plus 5 is equal to, that becomes 4. Transpose the 5, so this is 5 is equal to 4 minus 5, which is negative 1. Okay, so there we go. And now we can finally say that the coordinates of D are, so it's negative 7 and negative 1, and that is our answer. Moving on to the next question. Question 2.4 says, determine the equation of the straight line drawn from B, okay, so it passes B, and it's perpendicular to AC. Okay, so regardless of how it looks, we just know that it's drawn from B and it's perpendicular to AC. So I can't really assume that it's this line, okay, but I just know it's perpendicular to AC. So what do we know about perpendicular lines? Perpendicular lines, okay, something about their gradients is, if you take the gradient of two perpendicular lines, two lines that are said to be perpendicular, you are going to get negative 1. Okay, so that's what we're going to do. Since this line is perpendicular to AC, we need the gradient of AC to find the gradient of that line. So that will be our first step. Let's go ahead and find that gradient of AC. So A is negative 4 and 6, and we'll just take those points down. So the gradient of AC, we'll just find this by saying y2 minus y1. So I'll just go ahead and say 6 minus negative 2, which becomes a plus 2, all over negative 4 minus 0. Okay, so that becomes an 8, that becomes a negative 4. 8 divided by negative 4 is negative 2. Okay, so we know the gradient of AC. Now we know that that line, okay, regardless of which line it is, if you take its gradient and you multiply it by the gradient of AC, you are going to get negative 1 since that line is perpendicular to AC. Okay, so we'll just go ahead and say the gradient multiply by, and we know the gradient of AC, it's negative 2, and so this is equal to negative 1. So how do you solve for this gradient? This is multiplying, so the only way to get rid of it is to divide both hand sides by negative 2. And so all this means is that the gradient of this line we are referring to is 1 over 2. Okay, so we've got the gradient. To find the full equation of the straight line, we need the gradient and that value of C. We know that this line is drawn from B, so it passes B. So one of the points on that line is 3 and 5. So let's go ahead and find that. We know B is 3 and 5. I'll just go ahead and use y equals mx plus c here. So the gradient of a straight line is y is equal to mx plus c. We know the gradient, so y is equal to, that is a half, x plus c. And now to find c, substitute this point in place of x and y. So in place of x, we substitute 3. So this is a half times 3 plus c. And in place of y, we substitute 5. So this is 5. And if you multiply, they will become 3 over 2. Then transpose it becomes minus 3 over 2 equals c. Therefore, c is equal to, that can be 10 minus 3, which is 7. You can use a calculator, 7 over 2. So finally, the equation of this line is simply y equals a half x, and then c is positive 7 over 2. And that is our answer. And that is it for question 2. Question 3.1 says, if 2 tan theta minus square root 3 is equal to 0 and theta is greater than 180 degrees but less than 360 degrees, determine with the aid of a diagram sine squared theta plus cos squared theta. Okay, so we need to draw a diagram. Let's go ahead and start with our Cartesian plane. And the first piece of info they give us is that we have 2 tan theta minus root 3 is equal to 0. But we could just transpose that root 3 to make it positive. And that way we're just trying to find the value of tan theta. Okay, find out what exactly it is. So to get tan theta alone, we need to get rid of this 2, and we can do that by dividing both hand sides of this equation by 2. Therefore, tan theta equals root 3 over 2. Okay, so root 3 over 2 is a positive number. So in this particular quadrant, tan is positive. We know that tan is positive in the first and the third quadrant, okay? This is where we have all and where we have tan. And then they also tell us this. They tell us that theta is greater than 180 degrees but less than 360 degrees. Okay, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and finally 360 degrees. And so we know that theta is greater than 180 degrees but less than 360 degrees. So it's between quadrant number 3 and 4. But you can see that the quadrant that meets both requirements is quadrant number 3. Okay, tan is positive and it's also between those values. Okay, so we can draw a terminal arm and then a line up to the x-axis perpendicular to the x-axis. Okay, and so this is theta. We measure from 0 degrees all the way to there. That is the size of theta. And so we can see that from this information they gave us, tan theta equals root 3 over 2. We know from SOHCAHTOA that tan is opposite over adjacent. So opposite over adjacent, meaning the opposite side, okay, the side opposite this angle is root 3, and then the adjacent side is 2. So this is root 3, this is 2. But when you take a look at that, that doesn't really make sense because you see where this is. This is root 3. It's referring to a point. So we have a point and we went 2 units to the left and root 3 units down. Okay, these should be negative if they are the coordinates of this particular point. So this should be negative and this should be negative. So what happened is they were both negative and then they just divided and became positive. So grade 11s, always watch out for this scenario. It always has to do with tan, and it's specifically when tan is in the third quadrant. Okay, so this is what we have, and now we can actually find the hypotenuse. And then we can find what they asked us to find, which is just this. Okay, to find the hypotenuse, you see that we have a right angle triangle. We can simply use Pythagoras. So that hypotenuse, we call that the radius. So r squared is equal to, the longer side squared is equal to the shorter side squared plus the other shorter side squared. And let's go ahead and find this. So this is r squared equals, this will just give us 4, and that will just give us a 3 because the root breaks open. And so that is 7. So if you square root both hand sides, yes, we usually consider the positive or negative, but a radius is a length, so only consider the positive. R is equal to root 7. Okay, so this is square root 7 that we have over there. And now we can find the value of sine squared theta cos squared theta. So sine squared theta from identities, you know that this is going to be 1, but you still have to show them how you got to it. So sine theta is found by saying opposite over hypotenuse. So the opposite side over the hypotenuse, so that is negative root 3 over root 7, and then we square that, plus cos squared theta, so that is adjacent over hypotenuse, okay? So the adjacent side is, as we can see, next to that angle is negative 2, and then over root 7. So this is negative 2 over root 7, all squared. And let's get our answer. If we square negative, okay, it becomes positive. And if you square root 3, it will just become 3. So this is 3 over, and then that becomes a 7. Plus, this will become a positive 4, okay, when it gets squared, and then the root 7 becomes 7. We know that 3 plus 4 is 7, okay? So the denominators will stay the same because we are adding. So we add the numerator, denominator stay the same. 7 over 7 is indeed equal to 1, and that is our answer. Moving on to the next question. Question 3.2 says, if cos 20 degrees is equal to P, determine in terms of P the value of cos 340 degrees. And this is for 2 marks. So let's just think this through and just see whether we need a trig diagram or not, because this type of question usually requires a trig diagram. But from what they've asked you to find, you see 340 degrees. We can reduce that and we can actually get a 20 degrees here. So let's look at it like this. We have cos 340 degrees, and think about which quadrant that angle lies in. So it's an angle that is greater than 270 degrees but less than 360 degrees. So we know it lies in the fourth quadrant. And the reduction here is 360 degrees minus theta. So this is cos, and we have 360 degrees minus what gives us 340 degrees. That is minus 20 degrees. So if you reduce this, because it is in cos's quadrant, it just becomes positive cos 20 degrees, which we already know. Okay, they told us cos 20 degrees is P. So our answer is simply P. And that is it for question 3.2. Moving on to the next question. Question 3.3 says, simplify completely. And 3.3.1 gives us this trig expression and says we need to simplify this if theta is greater than 0 degrees but less than 90 degrees. Okay, that may be needed maybe in the second question, but not really here because we're not trying to solve for theta. All we're doing is simplifying this. Okay, so do you see how this, okay, the brackets look almost identical. We have 1, we have cos theta and cos theta, but then we have a minus and a plus. What does that remind you of? Difference of two squares. Okay, so if that's difference of two squares, we can actually simplify this by rewriting it like this. So because we have the exact same number here, okay, and then the exact same value here, and then just a minus and a plus, it can be simplified by squaring the first term, or just saying 1 times 1 is 1. And then this negative cos theta times positive cos theta is negative cos theta squared, okay, or negative cos squared theta. You could have also FOILed it out, which would have taken longer. I mean, it's not necessary to do that. And now that we have this, do you see that we have 1 minus cos squared theta? Remember from the identity, sine squared theta plus cos squared theta is equal to 1. If you make sine squared theta the subject, it means you're going to transpose cos squared theta and it becomes negative. Okay, so you have sine squared theta is actually equal to 1 minus cos squared theta. And so in place of 1 minus cos squared theta, we just rewrite sine squared theta. So this is finally equal to sine theta when we square root it. And that is our answer. That is the simplified. We're not really solving for theta, so right now this is not helpful. Moving on to the next question. Question 3.3.2 says we need to simplify this. So this is, let's just see what we need to do here. We have sine x minus 360 degrees. Grade 11s, always watch out for when your angle is negative. When the angle is negative, the simple solution to this is to add 360 degrees to it. So we're just going to add 360 degrees. And then what happens? It cancels and we'll be left with sine x. And then we have sine 90 degrees minus x. We can use cofunctions for that. And so that simply becomes cos x. And then we have tan negative x. Again, the angle that we have here is negative, so just add 360 degrees. If you did that, you would get tan 360 degrees minus x. But we know that 360 degrees minus x or minus theta, this is a reduction that lies in the fourth quadrant, in cos's quadrant, okay, where cos is positive. So this would reduce to negative tan x. Okay, so that's what we have there. All over, and then we have cos 90 degrees plus x. This is the only cofunction that changes to a negative. So this one becomes negative sine x. And now we just have to simplify. Because all of these are multiplying, they just become negative. So we can just cancel what we have in common. So this cancels with this. Then you've got, now I'm just looking at it as, they have now become positive because the negative divided by the negative is a positive. So tan x can be rewritten as, its identity is sine x over cos x. And we are still multiplying by a cos x. The denominator is gone now. And so those two cancel. And you see that all we are left with is sine x. And that is our answer. Moving on to the next question. Question 3.3.3 says, hence, determine the value or values of x for where x is greater than or equal to 0 degrees but less than or equal to 360 degrees if this same expression is equal to 0.5, which is a half. So you see how this expression simplified to sine x. That would mean that this is simply sine x is equal to 0.5. And they want us to solve for x. In other words, find not really the general solution, but specific solutions between this interval. This is a very simple type, one of the basic types that we are working with right now. You can either use your diagram or even the graph. Now, I'm going to explain it using the graph so that you can understand what we are doing. Instead of just saying things like, sine is positive, so we take this quadrant and that quadrant, you need to understand what is actually going on. So this comes from your trig graphs. You see the sine graph, which you can easily use a calculator to draw, you can just go ahead and find its y values. There are 4, really 5, x values you need to remember. So that is 0 degrees and then just count in 90 degrees, just like the cos diagram does. The cos diagram also does the same. So we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. And likewise here, but we just start with 0 and then 90 and then 180 and so on. Now you know that the sine graph looks like this. It reaches the highest of 1 and the lowest of -1. And from 0, you just need to remember these special points. Sine 0 degrees is 0. Sine 90 degrees is 1. Sine 180 degrees is 0. Sine 270 degrees is -1. And sine 360 degrees is 0. And so it creates this curve, this sine graph, like that. And so all we are trying to do is we're finding out where exactly is sine x equal to 0.5 or a half. Where's the sine graph? Where does the sine graph have a y value of 0.5? Because if we had to write this out as just the equation of sine x, we'd say y is equal to sine x. But this time, in place of y, they've substituted 0.5. So the question is, where is the sine graph? Where does it have a y value of a half? On the y-axis, you can see that a half would be in between 0 and 1. So this is a half. And you see that if I draw a horizontal line to find where exactly does this graph have a y value of a half, you see that it has a y value of a half at 2 points, over here and over here. How we find this is by simply finding the reference angle. So to find the reference angle, you just simply transpose sine, so it becomes the second function of sine. So that's our reference angle. If you say shift sine of a half on your calculator of 0.5, it's going to give you 30 degrees. So this angle is what we have over here, 30 degrees. And then what we have over here is, do you see how this works, the symmetry of this? With this graph, what this graph is doing over here, it does the exact same thing over here. So at 30 degrees, if you had a y value of a half, 0.5, you're also going to have a y value of 0.5 here as well, because this does the exact same thing as this. So from 0 degrees, if you go 30 degrees to the right, then the graph has a y value of a half. Then from 180 degrees, if you go 30 degrees to the left, you're going to have a y value of a half. And that is why we say 180 degrees minus 30 degrees. And that will be your next x value where you have a y value of a half. So 180 degrees minus 30 degrees, that is 150 degrees. If you did this using the cos diagram, you get the same answers as well. So let's put down our reductions. We'll just have theta, 180 degrees minus theta, and then 180 degrees plus theta, and 360 degrees minus theta. So if you were looking for, we already found the reference angle, and we would do the same. We'll find the reference angle in the same way. And so we would just ask ourselves, where is sine positive in our quadrants? And we know that that is in the first and the second quadrant. And that's why we would say, that just means that x is either equal to whatever this angle is, which is our reference angle, 30 degrees, or 180 degrees minus your reference angle. And then you get 150 degrees as well. So x is equal to 30 degrees or x is equal to 150 degrees. If you look for any solutions beyond this, they're going to be outside your interval. Because with this one, we say the general solution is 30 degrees plus k, 360 degrees. But you see, the problem with that is if you start adding, to this, your angle is going to be too big. If you substitute in place of k integer values, like try 1, okay, it's going to be above 360 degrees. If you try 2, way above, okay, and if you try -1, this is going to be way below, and so on. So we know these are our two answers. You could have used the graph or the cos diagram and you'd still get to the same answer. But it's best that you know your graphs very well because they will help you when you deal with trig functions. Moving on to the next question. Question 3.4 says, prove that 1 over cos theta is equal to all of this. Okay, so we need to prove that the left-hand side is equal to the right-hand side. You can see in this situation, the right-hand side is what we would work with because we can actually simplify things there. So we'll say right-hand side equals and rewrite it. Okay, so first, I already see from the answer, we have a cos theta left there. Okay, so we need to try to get that cos theta. The way we can get it is we're going to go ahead and rewrite tan as its identity. So this is cos theta over 1 plus sine theta. And we can just change this tan theta into sine theta over cos theta. Now these fractions are being added. And to add fractions, you need to ensure that their denominators are the same. So in this case, to make the denominators the same, we can simply make the common denominator to be cos theta multiplied by 1 plus sine theta. So this is what the denominator is going to become. For you to make this fraction have this denominator, you see that all that is missing is this cos theta. So if you multiplied this by cos theta, then you'd have this. But you see what you do on the bottom, you must do on the top. So you also need to multiply that top by cos theta. So that's what we are multiplying there. And then we get cos squared theta. And then looking at the second fraction, we have cos theta. How do we get this denominator to look like this? That would be by multiplying it by 1 plus sine theta. But what you do on the bottom, you must do on the top. So look at what we get here. I can just distribute. So sine theta times 1 is just positive sine theta. And then sine theta times sine theta is positive sine squared theta. Okay. And we can already see how this is going to simplify. Do you see how in the numerator you have a sine squared theta plus cos squared theta? That is the identity for 1. So that becomes a 1. Then you still have sine theta. And this goes all over cos theta multiplied by 1 plus sine theta. And then they cancel. So they simplify because they're exactly the same. So what is left in the numerator? There's actually an invisible 1 because all of this is gone. Okay, with all of that. There's actually a 1 because you're just saying this is common, so I divided by itself. So we have 1 in the numerator and in the denominator we have cos theta. And there we go. We have made the right-hand side look like the left-hand side. We have shown them that they are equal. So it is equal to the left-hand side and we have proven that identity. Moving on to the next question. Question 3.5 says, for which values of theta in the interval where, okay, theta is greater than 0 degrees but less than 360 degrees is the identity in question 3.4 undefined? So for which values of theta is this identity going to be undefined? A number or value is always undefined if the denominator is equal to 0. So do you see that in this identity, the denominators that we see is cos theta and 1 plus sine theta. If those are equal to 0, then our identity is undefined. So let's go. We'll just go ahead and tell them if cos theta is equal to 0 or if 1 plus sine theta is equal to 0, then the expression will be undefined. Okay, so we're just trying to solve for theta. It's like a general solution, but it's really specific solutions because we need to find it within this interval. So this will work a lot like this question. You can use the graph or you could use the diagram and you would find this. Okay, let's go ahead and solve here. What is our reference angle? If you say shift cos of 0, you're going to get 90 degrees, okay? Because you see the cos graph, 0 degrees and 90 degrees, that is that first angle that we have that has a y value of 0. You can also use your calculator and we know this is 90 degrees. Now, You can use the graph. You can also just use your diagram. Let's just quickly use the diagram just to find this. Where cos is equal to 0 or where cos is not negative, okay, where it's non-negative would be here, okay, in the first quadrant and in cos's quadrant. So this is just where it's not negative. So the reductions, we have theta and we have 360 degrees minus theta. So theta is finally equal to, I'm solving for theta now, we either say whatever the reference angle was, okay, theta, which is just 90 degrees, and then you can say plus k, but in this case, I'm not really going to do that because I can see that if I try to repeat, it's just going to go way above this interval. You can just to test it out, but there's really no use because it's not going to work. Or theta is equal to 360 degrees minus your reference angle, which is 90 degrees. 360 minus 90 is 270 degrees. And there we go. So these are our two solutions here. You could have also used the cos graph. So I know that the cos graph looks like this. And where it's equal to 0, where it has a y value of 0, is here at this 2 points, okay? From 0 degrees all the way to 360 degrees. I don't want to go beyond this. And the reason I was even saying this is because I was thinking about the way the cos graph looks. And so this is 90 degrees, this is 270 degrees, and there. So I know that at these 2 points, this is where the cos graph has a y value of 0 if we're looking at from 0 degrees all the way to 360 degrees. Okay, and then let's work with this one. So this is 1 plus sine theta equals 0. And let's see, if you transpose that 1, you get sine theta equals negative 1. So the reference angle here, if I'm not going to consider the negative, okay, so using this method with the cos diagram, you just say second function of sine, okay, and then you just say of 1. And that will give you 90 degrees. Okay, same angle that we get, same reference angle. So thinking about places where sine has a y value of, the sine graph has a y value of negative 1, using the graph, the sine graph looks like this, where it has a y value of negative 1 from 0 degrees to 360 degrees, okay, between the interval they referred to, would be here. This is where it has a y value of negative 1. It is at, so you can count it like this, 0 degrees, it has a y value of 1 at 90 degrees, y value of 0 at 180 degrees, y value of negative 1 at 270 degrees. So you can see that this is the only place that appears throughout. You could have also just used this, would be unnecessary, but you can. If you use the cos diagram, you see how you would still get to this same answer. You get to these two answers actually, because the thing is your reference angle is 90 degrees. Then you would need to find out where sine is negative. Sine is negative in the third and the fourth quadrant. This reduction here is 180 degrees plus theta. This one is 360 degrees minus theta. Well, 180 degrees plus 90 degrees is 270 degrees. 360 degrees minus 90 degrees is also 270 degrees. So you see how they just still give you 270 degrees. With this one, you can actually see what's going on. With this one, you're just finding actual angles. Okay, so we know that here, our angle is simply theta equals 270 degrees. So the only two answers that we have are 90 degrees or 270 degrees. And that would be our answer. Okay, moving on to the next question. Question 3.6 says, determine the general solution of theta in the following equation. So the equation is 2 sine theta equals negative root 3. And they say without using a calculator. Okay, let's go ahead and get sine theta first. So divide both hand sides of this equation by 2. Sine theta is therefore equal to negative root 3 over 2. Okay, so if this is what we have, we can just get the reference angle first. I'll just go ahead and use the Cartesian plane method, okay, to just simplify this. So let's go ahead and get that reference angle. To find your reference angle, don't consider the negative, just consider the absolute value of this, of sine theta. So we'll say shift sine, okay, because we're just like transposing sine, and we have root 3 over 2. So square root 3 over 2. And that is 60 degrees. Okay, so if this is 60 degrees, here is how we can find our answer. Using your cos diagram, you're now going to ask yourself, where exactly is sine? Where does it have a negative value? Where is sine negative? Sine is negative in the third and the fourth quadrant, We saw that in the previous question. So the reductions we'll use is 180 degrees plus theta and 360 degrees minus theta. And so we'll say that theta is finally equal to, we'll say 180 degrees plus 60 degrees, and this is a general solution. Remember that we are working with a sine graph. The sine graph repeats itself every 360 degrees. So 360 degrees later, you get the same pattern, okay? 360 degrees later, same pattern. Even before this, same pattern, okay? So we'll say plus k 360 degrees because that solution will repeat. And then to get the second solution, we say, or theta is equal to 360 degrees minus our reference angle, which is 60 degrees, and then plus k of 360 degrees again. And then you can just declare that k is an element of integer values. Okay, so theta is finally equal to, when we add that, we get 240 degrees plus k 360 degrees, or theta is equal to, that will give us 300 degrees plus k 360 degrees. And of course, you can't tell them where k is an element of integers, but we've already said this and it's already fine to just say it once because you're just declaring it so they know what k is. And these are our answers. And that is it for question 3. Question 4 says, sketch below are the graphs of the functions of f of x, which is equal to a sine kx, and g of x, which is equal to a cos x plus p, where x is greater than or equal to negative 180 degrees, but less than or equal to 90 degrees. Okay, so it goes from all the way from negative 180 degrees all the way to 90 degrees. So they want us to determine the values of a, k, and p. So it seems like a here stands for the same value. Okay, let's just look at the graphs and then figure out what exactly these graphs used to be. How have they tampered with it? And so because of that, what is a, k, and p? So the graph of f, that is the sine graph. You see how the sine graph looks interesting. Okay, so look at how it looks. It goes up and then goes down and goes up again. That's great because that's the way a sine graph usually looks. Okay, you just need to memorize the patterns that you have with all your graphs. You know that y is equal to sine x looks like that. Y is equal to cos x. That one looks like this. Okay. And then the tan x is the one that you can spot easily. You'll know that is a tan graph. So you see what I mean by it's following the same pattern, okay? It goes up and then down and then back, okay? But the only thing about this is the sine graph, right, usually does this within 360 degrees. So from 0 degrees all the way to 360 degrees, it creates this pattern. This one is doing this from negative 180 degrees to 0 degrees. How long is that? Okay, from negative 180 degrees to 0 degrees, that is a total of 180 degrees, meaning one cycle, this is one cycle, is completed in 180 degrees. Okay, so what that means is, since it's not completed in 360 degrees anymore, it means they did something to the number in front of x. So depending on the number in front of x, it's going to change that period. This period is now 180 degrees, meaning they actually added a, and look at how you can find it. Just take the old period, and if you divide it by the period that you have here, which you can see is 180 degrees, it completes one cycle in 180 degrees. If you divide it by that, you'll get 2. So you know the number that they added here was 2. Okay, because naturally to find the new period of a graph, you take the original period, okay, because it's a sine graph. Sine graph usually has a period of 360 degrees, and then you divide it by the coefficient of x, which is 180 degrees. That's why it has a period of 180 degrees, because the number they put in front of x is actually a 2. So now we know what k is. K is 2. So we'll put that down. I mean, I'll just leave it here for now. I don't know what I'm going to need there. So I know that k is 2. Great. Now, they also say a sine x. Okay, so a. Here's the thing about a. That a usually stands for the amplitude of your graph. The amplitude, the definition of an amplitude is the height of a graph from the middle, from the midline. So the midline or the middle of the graph can be found by taking the highest and then plus the lowest and then divided by 2. Okay. So in this case, you can see that, and you should always do that just in case they shifted it weirdly, okay, and the midline is not at 0, it's not on the x-axis. So you can see that the highest here is 2, the lowest is negative 2, okay. 2 plus negative 2 is 0, and then divided by 2 is 0. So you can see that that midline really is at 0, okay. And so what that means is the height of this graph would be from the midline to the highest point, and we can see that that would be from 0 all the way to 2 is 2. So we know the amplitude of this graph, it is 2. So that's just the amplitude. That doesn't for certain tell you what this is. It just tells you what the absolute value of this is. This could have been negative 2 and the amplitude would still be 2. And how you find out what it is based on the shape that it creates. Do you see that from negative 180 degrees? Okay, it's actually the shape and whether there was a shift or not. I can see that there was no shift because nothing was added to x. And so I know that it went from negative 180 degrees and then all the way to 0 degrees, and that was one cycle, meaning it's still following its original shape. It's not as if it looks like this. If it looked like that, that means they multiplied by a negative value in front of this sine kx, okay? So in this case, they didn't multiply by a negative value. It's clearly positive. And so we know now, because of that amplitude, it is indeed positive 2. Okay, so the value of A is 2. And yeah, that would also mean the value of A here is also 2. But we can still verify that. And then let's find the value of P. Okay, so I don't really need these anymore. Let's find the value of P in this graph of G. So the graph of G looks like this. Don't get intimidated by how big it looks. The reason it looks big is because they have not tampered with the period of the graph. If they did, then just like the sine graph, you would have seen that there would be something in front of x. But there's nothing in front of x. It's just an invisible one. So we know they didn't change the period, meaning this cos graph is still going to complete a cycle the way it normally does, from 0 degrees all the way to 360 degrees. But remember the shape that it normally makes, okay? If it's just y equals cos x, it just looks like that. And now how does that differ to this? Well, they definitely shifted it, okay? And you see that this shift is being applied to the x. When you apply a shift to x, you're shifting it to the left or the right. When it's applied to the y value of the graph, it's shifting up or down. So they have applied this to x, meaning we need to figure out how it was shifted. You could just think about what the original one would look like. You know that the cos graph starts from 1 and then goes down, hits 0 on the x-axis, okay, has a y value of 0, and then negative 1, okay, and then 0, and then 1. So how does that look with this one? I mean, I see here that clearly because this is 2, it just means that amplitude is changed. So instead of it reaching 1, it's going to reach 2. And instead of it reaching a lowest of negative 1, it will reach negative 2. So if you had to pick this up and then let it hit 2 like this, then from where it was originally to this point, how did we shift this graph? Well, it used to be here, okay, it used to have a y value of 2 at 30 degrees. And then we know that the original is supposed to have a y value of 2 at 0 degrees instead. So it means that this graph, it used to be this blue graph. It was shifted and became this graph. Let me just mark it in magenta. So like that, it became this graph, meaning that this graph is actually shifted 30 degrees to the right. Okay, so if you move the 30 degrees to the right, let's understand that with shifts, you have to first interpret it, okay, like say it's 30 degrees to the right and then actually write it here. When you're applying it to the equation of your function, if it was a right shift, okay, because remember we're applying this to x. If it's a right shift, you subtract. If it's a left shift, you add. So what this means is that this x plus p is actually x minus p. The value of p is a negative 30 degrees. So it's x minus 30 degrees. That will cause this graph to shift to the right. So that's how we figure this out. We know that naturally it should have looked like this with this blue graph, but since it had that y value of 2 at 30 degrees, it was actually shifted 30 degrees to the right. And that's how we find all of those. So we're just going to put those down. Okay, so we know that the value of A for both graphs is clearly 2. Okay, K is, we found K to be 2 as well. And we know that P is negative 30 degrees specifically because we were shifted 30 degrees to the right. And that is our answer. And moving on to the next question. Okay, question 4.2 says, what is the period of the function f? So you see that these questions are going to be really simple because we've already discussed it when finding these values. So the function f is that sine graph, and you can see that its period, remember, it completes a cycle in 180 degrees. So its period is 180 degrees, and that is our answer. It is 180 degrees. Moving on to the next question. Question 4.3 says, what is the range of g? So the range refers to all the possible y values of this function. So look at the graph of g and just look at all the y values that it has. With trig graphs, it's very easy to spot because they have a maximum and a minimum. This reaches a lowest of -2, and then it never goes beyond this. And then this reaches a highest of 2, okay, maximum of 2, and never goes above this. So we know that all the y values that exist on this graph will be values that lie between -2 and including -2, all the way to 2, and of course including 2. And so we would write it like this. You can say that y is simply all values greater than or equal to -2, but less than or equal to 2. Or you could write it like this. Y is an element of, we go from -2 all the way to 2, and then use square brackets to show that -2 is an included y value in this graph, and over here square bracket as well. And that is our answer. And that is it for this question. Moving on to the next question. Question 4.4 says, for what values of x, for where x is an element of -180 degrees to 90 degrees, that is still, that's our normal interval that they gave us, will f of x be equal to g of x? Okay, f of x stands for the y values of f. G of x stands for the y values of g. Where do we ever get a place where the y value of f and the y value of g are exactly the same for the same x value? Okay, so where do they have the same x value and the same y value? Where do they intersect? Just looking at it like this, you can see not one, it's like 3 places. Here, here, and here. So we need to find where they intersect. Okay, so we have to find the general solution of these. Okay, so let's go ahead and equate these graphs. So that is a sine 2x. So we know that is 2 sine 2x is equal to, and the graph of g is 2 cos x minus 30 degrees. Okay, 2 cos x minus 30 degrees. And you see that to do this and find these answers within this interval, working with general solutions. Okay, but then we're going to find those specific solutions. Okay, so to simplify this, we can get rid of the 2 on both sides by dividing both hand sides of this equation by 2. And so we have sine 2x is equal to cos, and this is x minus 30 degrees. And now let's go ahead and we can make both of them cos, because this is already cos. I'm just going to go ahead and make this a cos. So we use cofunctions for that. So remember how if we have cos 90 degrees minus an angle, it can be changed to sine A of that same angle. In the same way, we're going to use 2x as A, and so we change this to cos 90 degrees minus 2x is equal to, and then this is cos x minus 30 degrees. Okay, and now that we have this, let's go ahead and find our reference angle. So choose which one you want to use. You could have decided to put this on the left-hand side and this on the right, but I'll just keep it as it is. So if you transpose cos, you're going to get your reference angle. So the reference angle is equal to, you see, the second function of cos applied to cos x minus 30 degrees. Because this is the inverse of cos, and this is the function of cos, they would cancel each other. And all we are left with is that x minus 30 degrees. So this is x minus 30 degrees. And that is our reference angle. So if this is our reference angle, this is what we are making the subject of our equation. Okay, so we're dealing with cos here, and you're just going to take the standard reductions for cos. So that is where cos is positive. We'll take theta, and then 360 degrees minus theta. And we are going to say to solve for this, this is our subject. We're saying 90 degrees minus 2x, okay, because this is our reference angle, is equal to, and then whatever the reference angle is. The reference angle is x minus 30 degrees. But remember that this is a cos function, and so the cos graph repeats itself every 360 degrees. So will these solutions. We'll say plus k 360 degrees, or, and then we'll say again, 90 degrees minus 2x is equal to 360 degrees minus theta, and that is our reference angle, okay, which is x minus 30 degrees, and then again plus k 360 degrees. I'm going to just declare this here just in case I forget, where k is an element of integers, okay. And now let's just solve in each case and then find those specific solutions. So this is 90 degrees minus 2x. Okay, let's just transpose things. If you take this over, it becomes negative x. So this is negative 2x minus x, which is negative 3x, is equal to, if you have negative 30 degrees and you transpose this, it's negative 90 degrees, giving you negative 120 degrees, plus k 360 degrees. And then divide both hand sides of this equation by negative 3 to solve for x. So therefore here x is equal to, that will be positive 40 degrees, and then minus k, and that becomes 120 degrees. Okay, k 120 degrees. Okay, so we're done with that part. Or, and then over here we have 90 degrees minus 2x equals, this is 360 degrees minus x plus 30 degrees plus k 360 degrees. When these get added, they become 390 degrees. But if 90 degrees comes over, it becomes negative 90 degrees. So we have 300 degrees here. Now we still have this negative x. Bring it over, it becomes positive. X minus 2x is negative x. And again, plus k 360 degrees. Divide both hand sides of the equation by negative 1. And so x is equal to negative 300 degrees minus k 360 degrees. And now we're just going to find those specific solutions within this interval. So I'll keep that interval down. Okay, so I'll use a number line just so that this is more structured. And so remember that k is an element of integers. So we're going to substitute integer values just to look for our solutions and then ensure that it is within this interval. Okay, so this is 0. And if you substitute 0, you're just going to get 40 degrees. So 40 degrees is a value that is greater than negative 180 degrees, but less than 90 degrees. So we accept that answer. Then you can try negative 1. So in place of 0, if you substitute negative 1, we get 160 degrees. Unfortunately, you see that that goes beyond 90 degrees. So that doesn't work. And so because negative 1 doesn't work, I'm not going to try negative 2 because it's definitely not going to work. Okay. And then let's try positive 1. If we try positive 1 over there, we get negative 80 degrees. That is within our interval. Okay. And let's try 2 because 1 worked. So if we try 2, we get negative 200 degrees. And you can see that that is below our interval. That's not going to work. And so the only two answers that we accept here is the 40 degrees and negative 80 degrees. Okay. Let's try on this side with this. Okay, so we have, let's try 0 with our number line. So at 0, what do we get? We substitute 0, we get negative 300 degrees, which of course doesn't even work. It's not within our interval. Let's just try negative 1, and if it doesn't work, don't try negative 2. So negative 1, okay, that is 60 degrees. That works. Now we can try negative 2 because negative 1 worked. But unfortunately, negative 2 is a value that's way above 90 degrees, so it's not working. Let's try 1. Okay, so if you substitute 1 there, we get negative 660 degrees. Does not work. So the only value that works here is 60 degrees. And this makes perfect sense. You see how we have 3 solutions and we could see 3 values, okay? 3 points of intersection. So that makes sense. So we can finally tell them this means that x is equal to 40 degrees. Okay, let me just put it in order. Negative 80 degrees. Or x is equal to 40 degrees, and lastly, or x is equal to 60 degrees. And those are our answers. You can write them as x is an element of, and then you just put them in these braces, 80 degrees, then you're saying 40 degrees, and 60 degrees. Okay, and that is it for that question. Moving on to the next question. Question 4.4.2 says we need to find the values of x for which f of x multiplied by g of x give us a value less than or equal to 0. So the ways that we can get a value less than or equal to 0, with equal to 0, if either one of them is equal to 0, then we get 0. But with less than 0, if this is positive and you multiply it by a negative, you get a negative value, a value less than 0. If f of x is negative and you multiply it by g of x positive y values, you will get a negative. So this is what we are looking for, and let's see if we can find this in our diagram. Okay, so remember that this refers to the y values of these graphs. So when we are looking for where the graph of f's y values are positive, we know that positive y values lie here. So the graph of f has positive y values all through here because these would always map to y values that are positive. So whenever it's above the x-axis, it has positive y values. When it's below the x-axis, it has negative y values. So it has positive y values here, positive y values all through here. But for these same x values, okay, for all of these x values belonging to this part of the graph that has been selected, the graph of g should have negative y values. You see, the graph of g has negative y values if we're counting it for the same x values all through here. Okay, there. It's below the x-axis. It's below the x-axis, and then we stop here. It's still below the x-axis here, but unfortunately, the graph of f goes below the x-axis after negative 90 degrees. So it's just between these. Okay, negative 180 degrees all the way to negative 90 degrees. And we can put that down. So we know that x is greater than or equal to negative 180 degrees, because you can see that here at negative 180 degrees, the graph of f has a y value of 0. Multiplied by whichever, whatever y value that is, it will still give you 0, which is one of our requirements. Okay, so greater than or equal to negative 180 degrees, but less than or equal to negative 90 degrees. Okay, same story at negative 90 degrees. We can see that at that point, we have a y value of 0 for the graph of f. Okay, and then over here, does the graph of g ever go below the x-axis, okay, for these same x values of f? No, okay, it's just above the x-axis all through, unfortunately, so that doesn't work there, and that's fine. And now let's look for the second situation. Where is the graph of f below the x-axis? And then for the same x values, the graph of g is above the x-axis. So where's the graph of f below the x-axis? That's over here. That's where the graph of f lies below the x-axis. But for these same x values, the graph of g needs to be above the x-axis. You see that where the graph of g will be above the x-axis for the same x values as f would be starting from negative 60 degrees and then all through like that. Then we can't actually go beyond that. So it's these. So from negative 60 degrees all the way to 0 degrees. Because do you see how the graph of g, right, it has a y value of 0 at negative 60 degrees. If you take that y value of 0, multiply by whatever y value is here, you get 0, which is one of the requirements. And then it's above the x-axis, okay? And then at the same time, the graph of f is below the x-axis for these same values. So if you line all of these values that they exist for, do you see they are all these values in between negative 60 degrees to 0 degrees? So this is where x is greater than or equal to negative 60 degrees, but less than or equal to 0 degrees, okay? Because we can see that the graph of f at 0 degrees, it has a y value of 0. So 0 times whatever that y value is still 0. And this is where this works, okay? Between these. So we're just going to put those answers down. Okay, and these are our answers. Moving on to the next question. Question 4.4.3 says, so for which value of x will f of x divided by g of x be undefined? Okay, so we're taking the y values of f divided by the y values of g, and we need to see where it will be undefined. This one is very simple because you need to think about what makes a fraction undefined. A fraction will be undefined if the denominator is equal to 0. Okay, the numerator can be equal to 0, no problem, that's fine. Okay, 0 divided by 2 is still 0. That's not undefined. 0 is an actual number that we can quantify. Okay, But if the denominator is equal to 0, we can't define this, so it's undefined. And so we're just going to look for where the graph of g has a y value of 0. And that's it. So where does the graph of g have a y value of 0? Let me remove these. G, this graph has a y value of 0. Look at all its y values all through here. See? Y value of 2, y value of 1. And then once it hits the x-axis, that is where it has a y value of 0. Because this point over here is negative 60 degrees and 0. That is the y value. Okay, so we can see it only happens once. It only hits the x-axis at negative 60 degrees. This is where this will be undefined. So this is specifically at x is equal to negative 60 degrees. And that is our answer. Moving on to the next question. Question 4.5 says, what will the equation of h of x be if h of x is equal to g of 2x plus 30 degrees? Okay, so something is applied to g and it creates this new graph h. Just think about what g of x looked like. G of x just said g of x. But now do you see that in place of x, they have substituted 2x plus 30 degrees. And that's all you're going to do. Wherever you see x in the equation of g, replace it with 2x plus 30 degrees. So let's go ahead and take the graph of g of x, which we already had over here. Okay, so this is g of x. And wherever you see x, just replace it with 2x plus 30 degrees. So h of x is equal to, and I'm rewriting g of x. So this is 2 cos, but then I see x, and I'm going to replace it with 2x plus 30 degrees. Okay, so you see it's just alone there. I don't even need brackets to do anything. And so you're just going to say, continue with this, and we have minus 30 degrees. And this just simplifies to 2 cos, and those cancel. 30 degrees minus 30 degrees is 0, and we have 2x, and that is our answer. Okay, and that is the last question for question 4. So that is it for question 4. Question 5 says, in the diagram below, AM is the diameter of the bigger circle AMP. RPS is a common tangent to both circles at P. And then we also told that APB and MPN are straight lines. 5.1 says, give the size of angle P1. Okay, so angle P1, do you see how it is supported by this line AM? But they told us that AM is a diameter. So this is an angle supported by a diameter, meaning it's equal to 90 degrees because we have an angle in a semicircle. So angle P1 equals 90 degrees, angle in a semicircle. And you can go ahead and just make sure you put it down so you know that that is 90 degrees. Moving on to the next question. Question 5.2 says, show that BN is the diameter of the small circle. Okay, it probably works the same way this works. If this, okay, is equal to 90 degrees because it was supported by a diameter, then if BN is subtending a 90-degree angle at the circumference, then it makes it a diameter. Okay, so let's see. You can see that these lines are going across. They told us that these are straight lines, okay? We have these lines going across the line that helps to form this angle, okay, angle P1. This is MN, and this line APB. They are going across, meaning we have vertically opposite angles. So we can tell them that angle P1 is equal to angle P4, or really just angle P4 is actually equal to angle P1. Therefore, we know angle P4 is also equal to 90 degrees, and this is because we have vertically opposite angles. And now that this is equal to 90 degrees, you can see that BN is a straight line subtending a 90-degree angle, meaning it makes it a diameter. So tell them that BN is a diameter because we can see that it subtends a 90-degree angle at the circumference. Okay, we can refer to BN as a chord so long. The reason why is because we're just proving that it is a diameter. So long we'll call it a chord. So because this chord subtends a 90-degree angle at the circumference, it is a diameter. Okay, so chord subtends a 90-degree angle at the circumference. Moving on to the next question. Question 5.3 says, if angle M1 is equal to 70 degrees, calculate with reasons the size of the following angles. So we need to find the size of angle A. Okay, that is simple. You see that angle A is part of this triangle over here. This is 70 degrees, this is 90 degrees. Angle A is just the third angle in this triangle. So we can find it using the sum of angles in a triangle. So what is 180 degrees minus 90 degrees minus 70 degrees? And we know our reason. It's the sum of angles in a triangle. And so angle A is equal to 20 degrees. And that is our answer. Moving on to the next question. Next, we need to find the size of angle P6. Okay, I'm just going to fill in here as well that angle A is equal to 20 degrees. So how do we find angle P6? So angle P6 is this angle over here, and it's created by extending this line and this. Okay, so there we go. We have angle P6. So there's some ways we could go, but it's just going to lead to dead ends. So I don't want to say because vertically opposite angles, because then I get to this point and I can't really find this unless I try to use, I can't even use exterior angle of a triangle there. So let's just remember what this is. Remember how they told us this line SPR? They actually called it RPS, right? That is a common tangent. So if it's a tangent, then what do we know about the angle between the tangent and a chord? Okay, it is going to be equal to the angle at the circumference, which is supported or subtended by that same chord. So that is actually 70 degrees. It's equal to angle M1. So because of the tan chord theorem, so we'll tell them angle P6 is actually equal to 70 degrees because of the tan chord theorem. And that is our answer. Moving on to the next question. 5.3.3, we need to find the size of angle B for 3 marks. Okay, so we may need more than one step here. So this is angle B. We need to find the size of angle B. Okay, so to find angle B, if you're trying to find it in this triangle, we would need angle N. And I can't really see a clear way of finding angle N right now just because of where it is. So look at what we can do. You see how this is at the circumference. Think about theorems that refer to angles being at the circumference. One of the theorems we don't actually think about when we refer to this is the tan chord theorem, because the tan chord theorem still refers to an angle at the circumference. So remember how the angle between the tangent, okay, I'll just leave that tangent there, and the chord, okay, a chord, is equal to the angle at the circumference subtended by that same chord. So that means angle B is actually equal to angle P5. If we find angle P5, we find that. So angle P5, do you see how, you see these two lines, right? They go across. So it means that we have vertically opposite angles. And that means angle P5 is equal to angle P2. But you see that angle P2 is also the angle between this tangent and this chord. So it's equal to the angle at the circumference subtended by that same chord. So angle P2 is equal to 20 degrees. But then, and we can just start putting this down. We'll start by saying we can see that angle P2 is equal to 20 degrees because of the tan chord theorem. But we can see that angle P2 is also equal to angle P5, which is 20 degrees. So because of vertically opposite angles, angle P5 is equal to 20 degrees because of vertically opposite angles. Okay, and then angle P5 is the angle between this tangent and the chord, so it's equal to the angle subtended by that same chord. So there we go. Angle B is finally equal to angle P5. So I'll just say angle B is equal to angle P5. I think I should have, done that with those, but then it is equal to 20 degrees. So that is because of the tan chord theorem. Okay, angle B equals 20 degrees. And that is our answer. And that is it for question 5. Question 6 says, in the figure below, O is the center of the circle and PRST is a cyclic quadrilateral. Prove that angle R plus angle T is equal to 180 degrees. Okay, so we need to prove this theorem that says that the opposite angles in a cyclic quad are supplementary, that they add up to 180 degrees. Okay, because the focus is on angle R and angle T, we are going to construct like this. We're going to construct a radius from O to P and then from O to S. And then we can go ahead and call this angle O1 and this is angle O2. And make sure you write down any constructions made. Okay, and now to prove this theorem, we are going to use the angle at the center theorem. So you see how we have angle O1 at the center, and this angle is being subtended by PS, this arc PS. But we also have an angle at the circumference also supported by arc PS, and that is angle T. So we know that the angle at the center, angle O1, is twice the size of the angle at the circumference, which is angle T, because they're both supported by the same arc, and we'll put our reason down. Okay? And we can also see that in the same way, you see angle O2 is the angle at the center, and it is subtended by arc PS, but it's the larger arc, the major arc PS. But we also see that angle R at the circumference is also subtended by arc PS. So angle O2 is twice the size of angle R as well because they're supported by the same arc. Angle O2 equals twice the size of angle R, and we'll just put our reason down. I don't know why I said angle T2, it's just angle T. Okay? Now here's the thing about this. You see that we have we added these two together and we got 180 degrees. So we're going to add the angles that include them. Okay, so angle O1 and angle O2. Do you notice something about these? If we add these together, because they are the angles that lie around a point, they add up to 360 degrees. So we can go ahead and say, but we know that angle O1 plus angle O2 is equal to 360 degrees because angles around a point add up to 360 degrees. But we already knew that angle O1 was equal to 2 angle T. So 2 angle T plus angle O2, which is 2 angle R, and this is equal to 360 degrees. So to get angle T plus angle R alone, we just divide both hand sides of this equation by 2 because we can see the common factor of 2. And I'm just going to rewrite it in their order. Okay, 2 angle R divided by 2 is angle R, and that just gives us angle T. And 360 divided by 2 is 180 degrees. And there we go. And that is our final answer. And that is it for question 6. Question 7.1 says, complete the following statement. The exterior angle of a cyclic quadrilateral. Okay, if we have a cyclic quad, the exterior angle of a cyclic quad is equal to the opposite interior angle. Okay, so is, and we'll say equal to the opposite interior angle, or equal to the interior opposite angle. And that is our answer. Moving on to the next question. Question 7.2 says, in the diagram, M is the center of the circle and diameter AB is produced to C. ME is drawn perpendicular to AC such that CDE is a tangent to the circle at D. ME and chord AD intersect at F. Okay, and 7.2.1 says, if angle D4 is equal to X, write down with reasons 2 other angles equal to X. So angle D4 is equal to X. Okay, great. We have a tangent here, so this can really move around. So let's start here. If we can see that the angle between the tangent and a chord is X, then this is going to be equal to the angle at the circumference subtended by the same chord BD. So we can see that angle A is also equal to X. So we'll tell them angle A is equal to angle D4. Therefore, angle A is equal to X. And this is because of the tan chord theorem. Okay, so that's one other angle equal to X. What else is equal to X? So because we moved from here to here, I'll just start with this one. Do you see how they told us M is the center of the circle? So if M is the center of the circle, then AM is a radius and so is MD, okay, from the center to the circumference. So these two are equal. And so you see that they would have angles opposite their equal sides. Those angles opposite the equal sides would also be equal. Okay, so I'll just start off by telling them that those lines are equal. So AM is equal to MD because these are equal radii. And so since they are equal, these angles are equal. So angle D2 is also equal to angle A. because we have angles opposite equal sides being equal. And so therefore angle D2 is actually equal to x as well. So there we go. We've got two other angles equal to x. And moving on to the next question. Question 7.2.2 says, prove that CM is a tangent at M to the circle passing through M, E, and D. Okay, so prove that CM is a tangent. So this line, we need to show that this is a tangent, but specifically passing through the circles M, E, and D. So M, E, and D, we can see M is over here, E is here, and D is here. So I'm just going to draw a circle there so we can just work with that. Okay, so to prove that this is a tangent, MC is a tangent to this circle, look at what we can do here. Because we don't really have a center in this purple circle, what we can do is use the tan chord theorem. You see, if the tan chord theorem is true in this scenario, it would make this a tangent. So if we can find that the angle between this line, which is supposed to be a tangent, okay, we're trying to prove it's a tangent, the angle between this line MC and MD, which is a chord, that it's equal to the angle at the circumference of the circle, okay, subtended by the same chord. If these two angles are equal, then it means that MC is actually a tangent. So if the tan chord theorem is true here, this has to be a tangent. So the whole point is we're trying to show them that angle M1 is actually equal to angle E. If those two angles are equal, that's a tangent. So what we are required to prove is that angle M1 is equal to angle E. And let's focus on that. How can we show them that these two angles are equal? You can start from either one of them. I will start from angle M1. It can probably move around more. So angle M1, how do we get this? And how does it end up being equal to this? Okay, do you see how, and I'm going to need to just change this. Do you see how we have this triangle over here, right? And in this triangle, angle M1 is actually the exterior angle of this triangle. So, well, not really. Yes, it is, but you don't really have to use that method. What you can actually do is say that angle M1 is at the center, okay? And the angle at the center is twice the size of the angle at the circumference, of course, as long as they are subtended by the same chord or arc. So we can see over here that scenario, meaning this is 2x. And you see, it's nice that these are already named in terms of x. So once we find this, we just have to find out why is angle E equal to 2x as well. So I'm already saying that I've found angle M1 to be 2x. So angle M1 is equal to 2x. And we'll put down our reason. Angle at the center is twice the angle at the circumference. Okay, so we know that. And now let's find angle E. Okay, so do you see how we can actually to find angle E, we could use this larger triangle, because the thing is, I don't want to use this triangle here because yes, I can see that this is a radius, this is a tangent. The radius and the tangent are perpendicular at their point of contact, but then I don't know what M2 is yet. So what we could just do is use angle C. So looking at this triangle over here, because this, okay, is a radius, it's perpendicular to the tangent at the point of contact, we can find angle C. It will just be in terms of x. And once we find angle C, we will know what angle E is. Okay, so the focus is on angle C. We can tell them that MD is perpendicular to EC. So this angle, just call it MDC, that is equal to 90 degrees. Okay, so angle MDC is equal to 90 degrees. MDC equals 90 degrees, and that's because the radius is perpendicular to the tangent at the point of contact. And so now that these are perpendicular, now that we know that, we can find angle C. So angle C would be found by saying angle C equals 180 degrees minus that 90 degree angle minus 2x, and this is because of the sum of angles in a triangle. So angle C is equal to, that's 90 degrees minus 2x, 90 degrees minus 2x. And now that that is 90 degrees minus 2x, using this larger triangle, we can see that this is 90 degrees minus 2x, this is 90 degrees, and so we can find angle E. Okay, so angle E is equal to 180 degrees minus that 90 degrees minus 2x, and then minus 90 degrees. So saying minus this minus that, because that is a 90-degree angle since we have 90 degrees next to it. Okay, so that is angle E is equal to, that's going to be 180 degrees minus 90 degrees, and that becomes a plus 2x and then minus 90 degrees. You can see that negative 90 and minus 90 give you negative 180 degrees. So 180 degrees minus 180 degrees is 0, meaning angle E is just 2x. Okay, and this is because of the sum of angles in a triangle. I'm sure there was a shorter way to do this, but that's what I'm seeing right now. Okay, so now that we know that this is also 2x, we can conclude that angle M1 actually is equal to angle E. And so angle M1 is actually equal to angle E. And because they are equal, okay, of course, because they're both equal to 2x, it means that CM is really a tangent to the circle passing through MED at M. Okay, because the angle between this supposed tangent, okay, and the chord is equal to the angle at the circumference subtended by that same chord. So we can go ahead and conclude that it is actually a tangent. Okay, and the reason for this, I will not use the tan chord theorem. I'm not going to say the tan chord theorem is the reason, because the tan chord theorem is used when you already know that a particular line is a tangent. Here we were proving that this is a tangent. So because the tan chord theorem was true, it's a tangent. Therefore, what we are using is the converse of the tan chord theorem. And that is our answer. Okay, and that is it for question 7.2.2. Moving on to the next question. Question 7.2.3 says, prove that FMBD is a cyclic quadrilateral. Okay, I'm just going to get rid of all of these lines and only leave things like, I found that angle and that, those are fine. But we need to prove that FMBD is a cyclic quad. Okay, this shape. So remember the ways that you can prove a shape is a cyclic quad. There are 3 theorems, so 3 ways we can do this. Okay, the first way we prove that a shape is a cyclic quad is if we see that the exterior angle of this quad is equal to the opposite interior angle, then it means that this is a cyclic quad. The second way is if the opposite angles of the quad, they add up to 180 degrees, then this is a cyclic quad. The third way to prove this is if you notice that the angles in the same segment, okay, so the angles at the circumference subtended by the same quarter arc, that they are equal, then this is a cyclic quad. These are all theorems that refer to cyclic quads. They are specifically true if you are given a cyclic quad. Okay, so let's see what we can use here. Which one can we use? Well, I don't see lines going across, so I don't want to use that angle in a semicircle. I'll just rule that out for now. I also don't see, well, we do see some angles. We do see some numerical values like 90 degrees here and stuff. So let's hold on to those two. Okay, but for now, you know what? Let's actually go with this one, the opposite angles. And the reason I'm going with this is it's not just because of guessing. I'm just going to assume that they are, still going to follow this theme. Usually in Euclid, you will notice this. They will ask you to prove something, and then throughout the questions, they'll keep bringing that theorem back. So let's focus on that. The opposite angles of a cyclic quad add up to 180 degrees. So we would need to find out what exactly this angle is and what this angle is. Now this one is simple. We know this is 90 degrees, okay, because next to a 90-degree angle. So we know that this angle BME, or let's just call it BMF, it is 90 degrees. Okay, that we can clearly see already because they gave us that was 90 degrees. And so how do we find this angle over here? Well, do you see how this angle is subtended by a diameter? See, here's your diameter, here's AB, and then it's subtended by a diameter, so it means that it's actually equal to 90 degrees. So this angle, angle BDF, you can of course call it angle D3 plus angle D2, but I'll just call it BDF. That angle BDF is actually equal to 90 degrees as well. But the reason for this is because this is an angle in a semicircle. So angle in a semicircle, And then if you add them up together, if we say that angle BMF is added to angle BDF, then you see how they will add up to 180 degrees. Okay, that's 90 degrees plus 90 degrees. They give us 180 degrees. And so because they add up to 180 degrees, it means that the shape FMBD really is a cyclic quad. Okay, it's a cyclic quad. And remember the theorem that we used, because we saw that this theorem was true, then it means that we use the converse of it. Okay, we didn't say it's a cyclic quad, therefore we will be able to add up the angles and say they're equal to 90 degrees. No, we found out that the angles actually added up to 90 degrees. So you're going to say this is the converse of this theorem. So converse of the opposite angles in a cyclic quad or supplementary theorem really. Okay, the converse theorem of opposite angles in a cyclic quad. And that is our answer, and that is it for question 7. Okay, so that wraps it up for this paper. That is the last question, and I hope you guys enjoyed it. Please let me know if you have any questions, okay, in the comment section, and I will see you guys in the future videos.